Okay, what we're going to do is we're going to graph and identify some phase shifts and periods of the tangent graph and also cotangent. We're going to do two examples here. So example number one, what we have right here is the tangent. And if you recall, tangent has some different characteristics. All right, so if you take a regular tangent graph, the regular tangent function, okay, if we just think about this, always starts at pi over two, negative pi over 2. All right, it goes to 0 and then pi over 2. So we're just going to do one period here. And when we plug this in here, remember tangent is equal sine of x over cosine of x. And so when you talk about negative pi over 2, negative pi over 2 is right there, which is going to be 0 and negative 1. So what we have then is that's going to equal negative 1 over 0, and that realizes we have an undefined value, which is our vertical asymptote. Okay, so this is our vertical asymptote here at negative pi over 2. At 0, all right, we realize we have 0 over 1, which equals 0. That's our initial point. And then once again, we go over here, we have 0 and 1. So it's 1 over 0, which is, once again, undefined, a vertical asymptote. And so when we look at this is that when we transform this graph and we create a function of 1/3 tangent of x minus pi, well, what happens is that we are actually shrinking all of our y values. And so right here, this is actually going to make everything 1/3 smaller. So if we said these are our original values, we would have 1/3 the size of our original. So well, vertical asymptote just stays as a vertical asymptote. Other values, if you wanted to throw in pi over 4 in there, okay, negative pi over 4, the tangent negative pi over 4 right there is going to be negative 1. Okay, so if you wanted to throw that in there, so negative pi over 4, that would turn into negative 1/3. Okay, another one, if you want to throw in here, is pi over 4, because we know that 0, okay, 0 is going to be 0. Pi over 4, we know is going to equal actually 1. All right, 1. And so we have pi over 4, that's going to equal 1. And then we have one more, which is going to be pi over 2. All right, pi over 2, which is going to be our other vertical asymptote. Okay, oops, that's going to be 1/3 because it's 1/3 as big. Okay, so you can add some different values here, and this is our negative pi over 2. Now, we also have a phase shift. Okay, a phase shift. We're shifting this to the right. Okay, right pi units, right pi units. So that means I'm taking all my original values and I'm adding pi to get my new values. So right here, I'm going to add pi to negative pi over 2, which is going to give me a positive pi over 2. So if I start graphing this, right here, I'll have this at pi over 2. So originally it was right there. I'm using 5 pi units over here. So now we have this. That's my vertical asymptote. We have our, and I'm just going to go over here. This one is going to be adding pi units over there. This is going to be pi. Okay, and so we're going to have, this is going to be pi right there. We'll have another value there, which is going to be the negative 1/3. So if we add pi to this one, okay, and what we see then is going to be 3 pi over 4. 3 pi over 4. Okay, 3 pi over 4. And that's going to be negative 1/3. And so we go right there. That's negative 1. And that's going to be this like, boop, like that. It's going to go down like so. It's going to go up that, 0. And we go over here. It's going to give us 1 pi there. All right, that's going to be 3 pi over 2. All right, 3 pi over 2. 3 pi over 2. Okay, and we have our pi right there. Okay, that's going to give us 5 pi over 4. All right, and so we have, whoop. All right, that's our 1. It's going to be really small like that. So it's going to go like this, going to go whoop. I like making sound effects when I do this. So here's our 1 period, and that is what our graph's going to kind of look like for that 1 period of tangent. And if you put this in your calculator, you can see that tangent is going to keep on going through. The period remains the same because we just shifted it. And if you recall, the period of tangent, what does it start repeating? Is equal to pi. Is equal to pi. That's what we have there. All right, so we created our new set of points. All right, we have pi over 2 and vertical asymptote. We had, what was that one? 3 pi over 4 and our negative 1/3. We had pi and 0, 5 pi over 4, 1/3, and 3 pi over 2 and vertical asymptote. Okay, so by taking these values, we can write a new graph, and we have that right there. Okay, well, that's tangent. That wasn't too hard. All right, and I just did one period there, and we keep on repeating. All right, well, let's try another one. Let's go cotangent. Cotangent. Let's identify the period here. Well, cotangent, like tangent, has a period, all right, of pi. Now, if you recall from sine and cosine, we know that if you define the new period, all right, that's always equal to whatever the period of the function is, all right, divided by, all right, b. All right, so in this case, we're going to take pi divided by b, if there is a b value. Well, it just so happens that we do have one here, all right, and we have that right there, and we have cotangent, and we have 3 equals y. And so what we have there is our new period is going to be, well, pi divided by our b value, which is pi over 2. Pi over 2. And so then what we have there is going to equal 2. All right, 2. We have a new period of 2 for this function, this cotangent function. All right, well, let's also graph this. And if you recall, for cotangent normally starts at 0. All right, 0, that's a vertical asymptote. So I'm just going to do one period here. We go to our next value, which, right in the middle, that's going to be pi over 2. So pi over 2, that's going to be 0. And then finally, over here, we're going to have pi. Okay, and pi is going to be our other vertical asymptote. Okay, now just like the other one, tangent, if you recall, I threw in some pi over 4s, and cotangent is kind of like the same thing. All right, in our first quadrant here, if I throw in a pi over 4, our answer is going to be 1, because cotangent of pi over 4 is 1. And if I go over here, well, I'm going to go into the second quadrant, and that's 3 pi over 4, and that's going to equal negative 1. Negative 1. Because once again, when you think about the second quadrant, we have negative over a positive. Okay, or sorry, yeah, negative over a positive. Okay, so from here, my x values, my y values, we're going to do a new table, And so what happens to our new y values? Well, our original y values appear to be multiplied by 3. So we're going to multiply by 3 there. Our vertical asymptote just stays a vertical asymptote. That doesn't change. We have our 1 will turn to 3. Our 0 will stay 0. That negative 1 will turn to negative 3. And our vertical asymptote will obviously just stay a vertical asymptote. We are then taking this right here, and we're taking our original y value, or x values, and we're going to be multiplying by the reciprocal of this. Okay, so that's going to be 2 over pi. 2 over pi. Okay, so we're going to multiply everything by 2 over pi. That's going to give us our new x values. Okay, how do we get that? Well, right here, our b. If you kind of think about this, we are now changing our period. Instead of being pi, it's going to be 2. All right, so if we start here, we know this one's going to be 2. Okay, because it has to be this total period length. The middle one's going to be 1. And I'm assuming this one's going to be 1/2, because if you multiply this by right here, that's going to equal 1/2, and this is going to equal 3/4. All right, so if you have that right there, then you have multiply those, maybe, oh, sorry, 3/2. 3/2, not 3/4. 3/2, I apologize. 3/2 right there. So we have then, when we graph this, all right, I'll just change this, make it a little bit nicer. All right, I'm just going to graph these points. So 0, that's our vertical asymptote. We have a value of 1, that's our 0. At 1/2, we're going to go 1, 2, 3, boom. And so we can see this is going to be stretched out a little bit higher and go like that. All right. And then we have over here, we're going to go to 2. Okay. 2 right there. And then at the 3/2, we're going to go negative 3. 1, 2, 3. Boom. All right. Vertical asymptote. All right. And that's going to go down like so. Okay. And that's what we have. There we go. If you want to try to identify with these transformations, how does it affect our vertical asymptotes? Well, we know that with cotangent, our vertical asymptotes are always going to be n pi. And so when we have this, we're going to be multiplying this right here, okay, by both sides by, all right, 2 over pi, the reciprocal of that. And so essentially we're going to have one at every 2n, right? Every 2n. So every multiple of 2 will have a vertical asymptote. And that's how you can figure out where your vertical asymptotes are. If you want to figure out the vertical asymptotes over here, same thing, vertical asymptotes. Originally, they're pi over 2 plus and minus n pi. What we did was we add a pi to this. So when we add our 1 pi, well, we add it to this one. And so essentially what that's going to equal, all right, when we have that, is that we're going to have every, well, right here, we have 3 pi over 2 plus and minus n pi, and we'll get the next ones. All right, so if we take 3 pi over 2, we subtract 1 from there, we have pi over 2, and so on and so forth. So that's how we get our new vertical asymptotes. So whatever you have for your equation for your vertical asymptotes, all right, just do the, all right, either phase shift to that, add that value in there, all right, as we did here. Or if you have a b value or a combination, you simply just take that to whatever and multiply it through by the entire quantity, and you can get your answer that way. Okay? All right, so there we have it. 2 different examples on how to graph cotangent, at least one period of cotangent and tangent graphs. And these would just keep on repeating. All right, well, hope this helps you out. Good luck and God bless in the rest of your problems.